session of biofuel in this case, and I will share with you the presentation that will talk about GAN's alternative treatment, what we call EDO, which is enzymatic deoiling indeed. And what is that? What is enzymatic deoiling? Well, we have to tell that the composition of the wet gums produced by the water degamming process is approximately 50% moisture, 35% water-soluble content, and 15% of entrained oil, and naturally some trace meal fines. And due to that entrained oil, there is about 0.5 to 1% of the crude oil soybean losses when it's happening the centrifugal separation. And the enzymatic gums deoiling is a patented solution that can reclaim a portion of that entrained oil from the wet gums and simultaneously convert some phospholipid into diglycerides and fatty acids, also recovered with the oil. And that amount of recovery fatty matters is equivalent to 100% of the neutral oils in gums. So in that view, we can recover all the oil we are typically put into the gums to our main oil stream. Okay? We can recover all that fatty matter content. Well, this is the enzymatic degamming treatment typically, which is starting from phospholipids. We are adding water and some enzyme, PLC in this case. We'll remove a phosphatoester with a low molecular weight, but recover a diglyceride with a very high molecular weight. It's almost a little bit lower, but almost in the range of the phospholipid. So this is specifically what we recover, plus some free fatty acid, and then we are recovering in weight a lot of weight from the phospholipid, and also to have less neutral oil entrainment in gums. Important to say in this stage that what are the difference between the enzymatic degamming, which is completely different than enzymatic deoiling. Sorry, not completely different, has a lot of similarities in terms of the principle, the chemical principles, but since the point of view of what we do is completely different. And the enzymatic degamming treat 100% of the oil, what means big equipment, big amount of enzymes, high OPEX, and it's required to have a high phosphorus ppm. Typically, is only feasible with expandate when we treat the soya with expandate, which gives very high phosphorus content in oil, which is in the terms of expandate more than 1000 ppm. So it's completely different than enzymatic deoiling. What we said before, it is the enzymatic degamming, which is completely different than the enzymatic deoiling, which treats only gums. We have in that case the treatment of only 3% of the oil stream, 3% instead of the 100% of the oil. So naturally, this with a similar density, so it is much smaller equipment, a smaller amount of enzyme, which is the most important, which lead us to a much lower OPEX. The operational expenses, because of the enzymatic consumption is lower, so we will have also very, very low OPEX. And what is very important as well, which is independent of the phosphorus content. So if you have in your plant whether expanded or flakes, in terms always we are talking about soya, not only, but okay, it's one of the most important seed. So if you have flakes, because the lower amount of phosphorus in the oil is not a big deal, because we are only treat the gums. So that is what we will really expand enzymes. What you have after the water degamming. So if we look at the flow sheet of the enzymatic deoiling, it's quite simple. It's a bunch of equipment, vessels, but very simple equipment. The matter there, it is not into the equipment, but especially into the process. So we have somehow a preparation of the gums. We have an enzyme specification, which could it be PLC or PLC and PLA, depending on the amount of phosphorus remain you would want to have into the final oil. But then it is a reaction with vessels, reactors, where we have passing from one to the other by simple gravity. Are gums, but the behavior of these gums after the enzyme dosification is like a liquid, so can pass easily from one to the other without any pump or any other mechanical action. Finally, as we have a separation of oil or fatty matters like the diglycerides or free fatty acids and gums, we have a decantation. We don't need any other extra centrifugal machine. We have a decantation, and naturally we have the byproducts, which are oil and oil, which is the lighter product, and the gums, lysogums in this case, which is the heavier product, to be sent wherever, or to the DT in example. That's something that typically happen in places where it's possible to add some of this byproduct to the mill. But the oil is going again to the main oil stream. About why EDO? Why it is convenient to use enzymatic deoiling. The enzymatic gums deoiling process can easily be added to an existing water degamming system. It's no any additional centrifuge required, as we mentioned already, but also the fluidification of the gums in a liquefaction reactor allows to easily handling the material in all the reactors. And naturally, what is important is the maximization of the yield, which is about 1.2 to 1.4 we expect some higher even values of oil yield when compared with the gamine alone. So the extra yield, it will be about 1.2 to 1.4% of the oil production. And naturally, also some phospholipids are converted to diglyceride oil. Well, here we will see some of the figures of the pilot plant in Rosario in Argentina as part of one of the bigger plants in there. This is how it looks, the temperature profile of the process loop, where it is the gums coming from the gamine, water the gamine. It's required a cooling process to get the enzymatic reaction, some time for enzymatic reaction, but then it is necessary to increase the temperature to break the emulsion and separate easier the gums. So we increase the temperature up to about 85, 90 degrees to produce the decantation, and that's all. Some basic operational parameters of this flow. It is, as we mentioned before, the gums coming from the water degamine section. It is 85 degrees, but then it is mixed with cooled crude oil up to 40 degrees, which is make a combination, a mix of gums at 70 degrees C. But then still we need some lower temperature to make a good enzymatic reaction. So we still need to go lower temperature, some figures about 55 to 58 degrees C with gums liquefaction and the gums reactions, as we mentioned before. And then that temperature is being cooled somehow up to 53, 57, which is typical reaction, is typical temperature after of the reactors. Then goes to the oil and lysogams to 85 degrees C. We increase the temperature to break the emulsion and have the two products, the oil and the lysogams, that will goes to final disposal or to mill, typically depending the possibilities or not to add gums, in this case lysogams, as we mentioned, to our main product like meal. What is the advantage, among other things than mechanicals? The minimum enzyme consumption. It is diluted gums cooler to adjust the temperature for maximum enzyme activity. That's very important because the enzyme is the more expensive product in this operation. So it's critical to have a good enzyme activity. So we use all the enzymes we use. It is high share mixing to optimum enzyme and water distribution into the oil. But gum heaters to deactivate enzymes and optimize the gum separation. That's at the end of the process. And gums dilution with the crude oil is to increase enzyme activity as well. That's in the beginning of the process. And naturally, as we reduce the gums quantity, we reduce also the dilution of the meal protein into in our stream. In the solid stream. So for those countries where the protein content is the limitation, it is a very interesting option where we can minimize the impact of the low protein content of the seed. So some other pictures of the inlet product is a very sticky and viscous product, but this is how it looks like once we start the reaction. You can see much more liquid, but the final product, the recovery oil, is oil, like normal oil, and the lysozymes, which are a little bit more liquid. This is a plant view, a 3D model of a plant of a capacity of 3,500 tons per day. It's 11, let's say 11 by 11 meters footprint, and this is an 3D views with reactors. It's all we need, and or what is having more needs of room, and the decanter, the decantation, which is just simple decanter. It's not a centrifugation or any other complicated apparatus. So if we see what's in the payback, the key factors on the payback, it's the price differential, crude oil versus meal, naturally. So we are gaining all the crude oil instead of to sell like meal. When we added the gums into the meal, we are recovering that part, even depending on the protein content. With when you don't reach the protein content in meal, you will be penalized with a lower price of the meal. So enzyme cost also, every time the enzyme costs are being lower and lower, and this as well as we mentioned, in this case, the amount of enzyme will depend only on the amount we will ready to react, not on the oil basis, but on the gums production basis. Extra yield depend on the enzyme times, gums quality, equipment design. Naturally, that's technology, that's our part. And the present gums in oil, flake or expanded, is depending for basically due to fixed cost. So this is a typical payback for a 3,500 tons per day plant, which we reach it, not 100 but 104% of the neutral oils in gums, with an oil value difference in between meal and oil, which is not fully true. Well, I mean, it's true, but it's a very conservative way of looking this thing, because indeed we have in many cases we are not able to add anything to the meal. So indeed this difference is almost the full price of oil, means about 650 US per ton. So naturally, this the payback of this would be much better. In this case, okay, 330 days per year in operation, and the enzyme cost about $16 per kilo, which is about 75% of the market cost, but it's something that many of the, well, not many, but the enzyme supplier is ready to give this kind of discount. And when you see about the cost, the benefit per year is about $900,000 per year by the oil, but using this about half of the real price. So if you put, depending on your financial business, but it will be maybe double of this, the benefit per year. But it's something to discuss every case. But well, okay, even considering this very conservative figure of recovery, of the valuation of the oil recovery, we have about not even 2 years, 1.7 years. So the payback is lower than 2 years, with the oil recovery amount of only, I mean, it could be even higher, but 100% of the oil, like warranties. But expected is 110, 120% of the oil incomes. The oil quality, final, it will be in free fatty acid an increase in 0.15 to 0.17 extra free fatty acid in the final oil, and 0.4 to 0.5 extra and diglycerides in the final oil. So it is quality that is typically sold when you use enzymatic degamming. But in this case is enzymatic de-oiling, which is different and make a lot of more value, as we were mentioned. So thank you for your time and attention, and we are at your disposal for any questions or comments. You can see over there my mail, so you can contact me whenever you want. Thank you so much for your attention once again. Bye.